Hello everyone, Assalamu alaikum. In this tutorial series I am going to complete my smiling dino project. So basically there will be three parts: making the model, and then I will be collect data to train the model, and then I will be connect the game with the model. So let's see the game demo here, and you can see when I am opening my mouth or smiling, then the input is taken by this game. So it's just a simple game. Okay, now in this part I am going to make the model. So let's import TensorFlow. So here you can make a project named as smiling dino, and under this file folder you can keep model.py. I will be required more than one py file and more than one folder to keep to make this project. So follow me as it is so that it will be easy for you. Just import TensorFlow stf. Now x equal to, write out the input equal to x tf dot chars dot layers dot input, and pass out the shape. So the image which I am going to feed to this model is 100 by 100 image, and it's a 3-channel image. That is why I am giving her 3. Then x equal to tf dot chars dot layers. Then I am going to use a conv layer, conv 2D, and here I am going to use 64 filters out there, and kernel size, give the kernel size out there. So I am going to use here 1 by 1 kernel here, and activation function. So as activation function in this layer I am going to use rectifier linear unit, and then I will be keeping the padding same, and here just give the input. Then again x equal to tf dot chars dot layers dot, now I am going to use a max pool layer. So max pool 2D. So give pool size out there. So pool size will be 2 by 2. Then give strides. So strides will be again 2 by 2. Now keep the padding here. So as usual, keep padding equal to same, then pass out there x. Now again x equal to, I am going to use again a conv layer. So tf dot chars dot layers dot conv 2D. Then I am going to use 128 filters here, and here the kernel size I am going to change from 1 to 3. So write out there 3, and keeping the same activation function, rectifier linear unit, and keeping the same padding, pass out there x again. So I have done with 3 layers here. Now again tf dot chars dot layers dot, I am going to normalize this. So I am going to use a batch norm here. So that normalization, and pass out there x. And now I am going to use a max pool layer. Use here max pool 2D, and pool size again. Now I am going to use a pool size of 5 by 5 here, and here I am going to strides for 2 by 2 strides, and give the padding here same, and x. Now I am going to make another conv layer. So tf dot chars dot layers dot conv 2D, and here I am going to use 256 filter. So in the first layer I have used 64 filter, and in the second layer of convolution I have used 128 filters, and in the third layer of convolution I am going to use 256 filters. So the number of filters are gradually increasing here. 256 kernel size. I'm going to change the kernel size here 5 by 5. And activation function, as activation function I am going to use a rectifier linear unit and keep the same padding and pass out there x, and x equal to tf.keras dot layers dot. Now I am going to perform max pooling here. So max pool to the and pool size of, okay, so pool size of 5 by 5 here, and stride out there 2 by 2, and padding here same padding, and you can change this pool size from 5 to 2. Just change this one. Okay, so I have used 3 max pool here, 2 and 5 each of stride of 2. Okay, now what I can do here, again another batch normalization here. So x equal to tf dot keras dot layers dot batch normalization and pass out there x. Okay, now again I am going to perform convolution here. So tf dot keras dot layers dot conv, so conv 2d here, and here I am going to use 512 filters and kernel size of 3 by 3, and activation function I'll be using rectifier linear unit, and as always I'll be keeping the padding equal to same. Pass out the x. Now again I am going to use another layer of convolution, tf.keras dot layers dot conv 2d, and here I am going to use 256 here, and kernel size equal to 3 by 3, or you can use here 1 by 1. I'm using 3 by 3. If you use 1 by 1 then it will be a bottleneck. Padding equal to same, then x equal to tf dot keras dot layers dot conv 2d, and use here 512, and kernel size, give the kernel size equal to 3 by 3, and activation as usual rectifier linear unit, and keep the padding equal to same, and pass out there x. And here what I am going to do is, in this layer I am going to change the name, and I am going to give this name as layer 9. Okay, so give a different name here. Just give what should I give? Y. Okay, y equal to x. Keep y equal to x here. Now I am going to add a resnet here, or residual block you can say. So x equal to x plus y here. So what I am going to do, I am going to add this layer with this layer and make a residual block here. Okay, and here again x equal to tf dot keras dot layers dot conv 2d, and use here 124 filters, kernel size of 3 by 3, and activation as usual rectifier linear unit, and keep the padding as usual same, and pass out there x. Now I am going to flatten this layer. So x equal to tf dot keras dot layers dot flatten. Now pass x here. So again x equal to, I am going to use some fully connected layers here. So keras dot layers dot dense, and here I am going to use 124 neurons, and activation perform rectify linear unit, and pass out there x equal to tf dot keras dot layers dot dense. Now I am going to use 512 filters, and activation as usual I am going to use rectify linear unit, and pass out there x, and x equal to tf dot keras dot layers dot dense, and 256, and give the activation here x, and the last layer, which will be the output, equal to tf dot keras dot layers and use dense, and I am going to use 1 here, and activation I am going to use sigmoid here, and pass out there x. So let's make the model now. I got input, you can give any name here, you can give input layer, input, or any other name, the name doesn't matter here, and here you can give any other name, the name doesn't matter here. So let's create the model with this input and output. Model equal to tf dot keras dot model, and pass out their input and pass out their output. Let's see the summary of the model. So if you don't cannot follow me here, don't worry, I'll be giving the link of GitHub code, so don't worry. Okay, I got an error. Input has undefined rank. Okay, I got the error. I forgot to pass x here, so pass x out there. And it is a good practice not to use bias in front of batch normalization, so just write out there false. Okay, now everything should fine. Run the code. So this is my model summary here, and here you can see I put an input shape of 100 by 100 by 3, then convolutional layer, then max pull, and then conv layer, batch normalization, max conv pooling, then max batch normalization, then conv layer, 3 conv layer out there, and then I have done a residual block here, and then conv layer and flattening, and then some 3 dense layer out there. One of neuron is 1024, the second one is 512 and 256, and then neuron number is 1. Okay, so I'm done with the model creation. In the next tutorial I will be collecting data, and I will try to train this model. So this is all. As always, thanks for watching, and don't forget to subscribe to appreciate my effort. Thank you.